Hello everyone, welcome back to Mathverse by Vishal. So this is one of the thought-provoking question from the chapter Definite Integration which appeared in JEE Advanced 2021. Now let's see how to tackle these kind of questions when it comes up in the next upcoming JEE Advanced session. So totally four functions are given to you: psi1 of x, psi2 of x, f of x, and also g of x. So in option A and B, they are talking about only psi1 and psi2 functions. So let's try to analyze them. First thing, given that this psi1 of x is equals to e power minus x plus x, and then they are talking only for x greater than 0 interval. So we have to check whether this psi1 of x function is less than or equals to 1 or not. So obviously I'm going to differentiate this one. So if I differentiate, I will get psi1 dash of x is equals to 1 minus e to the power of minus x. Okay. But what do we know? When x is greater than 0, e power x will be greater than e power 0, that is 1. Whereas e power minus x will be less than 1. So what's your pure observation here? In this psi1 dash of x, e power minus x is a value which is less than 1. And totally, if you notice, this is 1 minus e power minus x, right? So if e power minus x is less than 1, can I say this is completely a positive value always for x greater than 0? So that makes it psi1 dash of x is always positive. So if the derivative is positive, we know that the function is going to be an increasing function. So let's conclude psi1 of x is an increasing function, is an increasing function. And then for increasing functions, what I can do here, when x greater than 0, I can say that psi1 of x greater than psi1 of 0. But already psi1 of x function is there. So let's find out this psi1 of 0. So psi1 of x greater than psi1 of 0 is nothing but e power minus 0 plus 0. But e power minus 0 is clearly 1. So finally what you're able to conclude is psi1 of x is greater than 1. But look at the option 1 actually. They have given you psi1 of x is less than or equals to 1. So which makes clearly option A false. So once again this is an application of increasing decreasing functions. Okay. Now let's go for option B here. They are talking about psi2 of x. So obviously I'll be taking psi2 of x function here. Okay. But the process is going to be absolutely same. Psi2 of x is given as x square minus 2x minus 2 into e power minus x plus 2. Okay. And once again, they are talking about only x greater than 0. So once again, let's try to differentiate and check it. Psi2 dash of x is equals to, this will be 2x minus 2 and plus 2 e to the power of minus x, and after differentiating, right? But just by looking at this, we will not be able to tell whether it is a positive or negative value. That is why I'm going to double differentiate this function. So psi2 double dash of x is equals to 2 minus 2 into e power minus x. Now look at the advantage here. It is 2 into 1 minus of e power minus x. But if you observe carefully, just here in the previous step, we have already concluded that this value 1 minus e power minus x is less than 1, but moreover it is going to be a positive value, right? Because e power minus x value when x greater than 0 will be lying in between 0 to 1. So which makes this always positive. Okay. And then if this is positive, you can conclude that psi2 double dash of x is positive. But if the double derivative is positive, I can say that the first derivative function is going to be an increasing function. Okay, because the second derivative value is positive, first derivative is going to be increasing. And if the first derivative is increasing function, let me take the inequality for x greater than 0. Since it is increasing function, I can say that inequality doesn't change. If I apply the function on both sides, psi2 dash of x will be greater than psi2 dash of 0. Okay. But you can calculate psi2 dash of 0 here because you have the function with you already. So put x is equal to 0 in that. So what we get is this is greater than 2 into 0 minus 2 plus 2 into e power minus 0. So clearly this is 0 minus 2 plus 2, which makes it completely 0. So what you are able to notice is psi2 dash of x is again greater than 0. So once again, psi2 dash of x is greater than 0. What's the conclusion? Again, it's an increasing function. So that makes it psi2 of x is increasing function. It's an increasing function. Once again, if it is increasing function for x greater than 0, I can say that psi2 of x will be greater than psi2 of 0. But look at the function psi2 of x here. If you put x is equal to 0, what you are going to get? Look at this one. I'm going to write it here. Psi2 of 0 will be 0 minus 0 minus 2 plus 2, which is again 0. So psi2 of 0 is clearly 0. So finally what you can see is psi2 of x is greater than 0. So this is the conclusion for psi2 of x. But what is the option B here? They said that psi2 of x is less than or equals to 0. But what we got is greater than 0. So which means the option B also false. So once again, it's a pure application of increasing decreasing functions. Okay. Now let's take the option C and D. First we'll go for option D because the function g of x is looking somewhat simpler. And in the option D, you have to verify this inequality. So option C and D are very important. This kind of questions appeared in the previous advanced also. So first let's take the function g of x, right? So given that g of x is equals to integral 0 to x square square root of t into e power minus t of dt. Okay. Now what I'm going to do is I'll simply use the expansion of e power minus t. So let's write down the expansion of e power minus x first of all from the limits chapter we know, right? E power minus x is equal to 1 minus x plus x square by 2 factorial minus x cube by 3 factorial and then so on. Okay, so this is our expansion of e power x. So why do we need e power x expand e power minus expansion means because if you look at the options, clearly this right hand side part are looking like some expansion terms, right? So that's where you have to get the idea from. So what I'm going to do is here I'll take two cases. Now in this case, first thing what I can do is I can say that e power minus x will be greater than or equals to 1 minus x because if you look at this, if I cut the expansion exactly at minus x. I can say that this 1 minus x will be definitely less than or equals to e power minus x. But similarly, what happens if I cut the expansion at this point here? If I cut the expansion here, then I can say that e power minus x will be less than or equals to 1 minus x plus x squared divided by 2 factorial. What's the reason behind that? Because if you are cutting the expansion, which is alternating plus or minus, if you cut it minus sign, then that value will be the lesser value, right? Lower bound. Similarly, if you cut the value after a positive term, then that becomes the upper bound there. So that is why for e power minus x, I can take the upper bound as this and lower bound as 1 minus of x here. So that is what I'm going to make use of here. So let me substitute the function g of x, right? So g of x is equals to integral 0 to x square. This is square root of t into. Now I can say that e power minus t e power minus t will be definitely less than or equals to 1 minus t plus t square divided by 2 factorial, right? But if I try to multiply it by square root of t, I can say that square root of t into e power minus t less than or equals to, obviously this will be square root of t multiplied by 1 minus t plus t square divided by 2. So that is what I am going to write in the question also here. So which means I can say that this g of x function will be definitely less than or equals to, okay, because you understood that root t into e power minus t is less than or equal to this value, right? That is why g of x will be less than or equals to integral 0 to x square root t multiplied by e power minus t upper bound is 1 minus t plus t square by 2 factorial is 2 and whole multiplied by dt. Now you can expand the remaining. So the first term is going to be integration of square root of t dt minus of second term will be integration of t into t power 1 by 2 which will be t power 3 by 2 of dt and third term will be 1 by 2 into integration of square root of t into t square will be t to the power of 5 by 2 of dt. So if you integrate completely, you're going to get this is less than or equals to t power 1 by 2 integration, right? So this is going to be t power 3 by 2 divided by 3 by 2 where the limits are from 0 to x square minus of t power 3 by 2 integration t power 5 by 2 divided by 5 by 2 limits are from 0 to x square plus 1 by 2 into t power 5 by 2 integration will be t power 7 by 2 divided by 7 by 2 where the limits are from 0 to x square. Now you can substitute the limits and simplify and verify whether the option D is correct or false. Okay. So g of x is less than or equals to, let's do the calculation 2 by 3 into, if you put the upper limit, this becomes x cube obviously and then minus of this will be 2 by 5 into, if you put a upper limit x square, this becomes x to the power of 5. And then here one of the two gets cancelled, right? So remaining part will be 7, 1 by 7, sorry, multiplied by, if you put a x square, this becomes x to the power of 7. Okay, so finally, this is the inequality you are able to get. G of x is less than or equals to 2 by 3 x cube minus 2 by 5 into x power 5 plus 1 by 7 into x to the power of 7. Let's look at the option D here, which is exactly given in the option D here. G of x is less than or equals to this. Okay. Now, which means obviously option D is correct. Since it is a single correct, we know the option D is going to be the correct answer, but you should also know how to simplify the function f of x also, right? So I'll give you the hint for this one. Now I'll leave the solving part for you to try later. Okay. So let's take the function f of x also here. Given that f of x is equals to integral minus x to x, this is mod t minus of t square whole multiplied by e power minus t square of dt, and once again this is for x greater than 0. So first thing you need to notice one thing, that this is an even function because mod t is even, t square is even, e power minus t square is also even. So which means you can write your integration as 2 times of integral 0 to x. Now it is positive, right? So this becomes t minus t square of e to the power of minus t square of dt. So if you split the integration, this becomes integration of 0 to x. This will be t into e power minus t square of dt, and then minus of 2 into integral 0 to x. This will be e power minus t square multiplied by t square of dt. Okay. Now the first term can be simplified very easily because you have directly e power minus t square, right? So directly put t square is equal to z and try to solve the first term here. Okay. And then again for second term you have to use the property again, because just now I gave you one simple logic here. What is that? E power x is definitely greater than equals to 1 minus x, right? So I'm going to make use of that. E power x is greater than equals to 1 minus of x. So here what we have is e power minus x square, right? So I'm going to write e power minus, sorry, this is e power minus x greater than equals to 1 minus x. So e power minus t square will be greater than equals to 1 minus of t square. But you need e power minus t square into t square, right? So if you multiply, this will be t square into e power minus t square will be greater than equals to t square minus t power 4. T square minus t to the power of 4. Need is this is minus 2 times, right? So I think you understood now what to do. So if you want, I can do it, no problem. So I can say that minus t square into e power minus t square will be less than or equals to t power 4 minus t square. So finally, what we can say is this f of x function will be definitely less than or equals to, you will be able to solve this part, right? If you put t square is equal to z, this becomes integration of dz, and 2t dt becomes dz and e power minus of z. And what about the limits here? This becomes 0 to x square. Now you know how to integrate the first term. I will leave that calculation part to you. And what about the second term? We understood that this minus of e power minus t square into dt is less than or equal to t power 4 minus t square, right? So I'm going to put that here. So plus 2 into, this will be integral 0 to x t to the power of 4 minus of t square of dt. So now just integrate this one and substitute the limits here and try to verify the option C here. Okay. So this is the idea behind this option C and D, which is very, very important. That is, you should know where to cut the expansion. So once again, how did we cut the expansion? The simple logic is when you are having this decreasing function and also alternating plus or minus symbol expansion, if you cut after a negative term, then that becomes the lower bound like this. Lower bound means e power minus x will be greater than or equal to 1 minus x. Okay, so this is the lower bound here. And similarly, if you cut after a positive term, then it becomes an upper bound. That is why I can say that e power x minus x should be definitely less than or equals to 1 minus x plus x square by 2 factors. So this is called upper bound here. So remember that logic. Okay, when to cut at minus and also plus, and that is also based on options completely. Okay. And if you simply expand this expansion, I mean the integration, you can verify that option C is also going to be false. Okay. Now you try to do it by yourself so that you'll be able to do this kind of questions later when it comes up in the examination. Okay. Now, this is a paragraph question which contains two questions. So, the question which we have solved now is only the first part, and we have the second part also, which carries totally 6 marks because it is a paragraph question, right? So, let's look at the second question of this paragraph. Which of the following statements is true? So, let's go for option A and D first of all. Given that f of root of ln3 plus g of root of ln3 is equal to 1 by 3. So, don't start finding out f of root ln3 and g of root ln3 separately because there is a small trick here. First thing, we have already calculated this f of x function, right? So let's take this f of x function and directly put it here. Okay, we have simplified f of x function already, right? So let's take that and put it here. So this is your function f of x. Okay, but let's try to simplify the function g of x further. So g of x is given as integral 0 to x square. G of x function is given as integral 0 to x square root t into e power minus t dt. Root t into e power minus t dt here. So if I want to add these two functions f of x and g of x, there is a clear problem because the limits are not same. That is why what I'm going to do is in the second function g of x, I'm going to put root t is equals to some u. Okay, so that the question changes to g of x is equals to integral 0 to, if you put t is equals to x square, then u becomes x, the upper limit, and root t is u multiplied by, this is e power minus t. So, and which clearly says t is equal to u square, right? So, this becomes e to the power of minus u square. Moreover, if I differentiate, dt will become 2u du. So, finally, you get 2u into du. And if you look at this, finally, you get g of x is equals to 2 into integral 0 to x u square into e power minus u square of du. So this is your function g of x. So this is a trick here. Don't try to calculate f of x and g of x separately because we need f of x plus g of x function. So let's try to add these two directly. F of x plus g of x will be is equals to, now clearly you can take 2 common. Moreover, the main advantage is you can see that the limits are same now. So this becomes integral 0 to x. You can take e power minus t square also common, and remaining part will be t minus t square, and here plus t square. The u square you can change the variable, right? U square is same as t square because I'm changing the variable when adding. So clearly this t square gets cancelled. So finally what we have is simple function f of x plus g of x is equals to 2 into integral 0 to x e to the power of minus t square of t dt. So finally you can put here t square is equal to z, so that 2t dt becomes dz. So what about the limits here? This will be integral 0 to, if you put t is equals to x, this becomes x square by z value. So this becomes finally integral 0 to x square, and 2t into dt is dz, and t square is z. So this is e to the power of minus z. You know how to integrate, minus e to the power of minus e power z, and finally e to the power of x square. So if you substitute the limits, what we get is f of x plus g of x will be is equals to minus of, when you substitute the upper limit, this will be e power minus x square minus e power 0 is 1. So which means your final value is 1 minus e to the power of minus x square. Now you look at the option 1. We want f of square root of ln3, right? So that you can put x is equals to square root of ln3 to verify for the option 1 here. F of square root of ln3 plus g of square root of ln3. And this should be is equals to 1 minus of e to the power of minus square root of ln3 whole square will be ln3. Okay. And finally, what is the value that we are having here? E to the power of minus ln3, which is 1 by 3. So 1 minus 1 by 3, which is equals to 2 by 3. Now let's look at the option 1. So they are saying it is equal to 1 by 3, which is absolutely false. Okay. So this is the trick here. Don't try to calculate f of root ln3, g of root ln3 separately. Instead, calculate f plus g first and then try to put the value root ln3 as x. Okay, now. And then this is option 1, right? Let's go for the option D, which will be somewhat easy here. Because if you want to find out whether f is increasing or decreasing function, you need to differentiate it first of all. So let's do it here itself by using Leibniz rule. Okay, so f dash of x is equals to 2 into, we know how to differentiate using Leibniz rule. So I'll put the upper limit in place of t. So this becomes x into x minus x square multiplied by e to the power of minus x square and into 1 since you are using Leibniz rule here. And if I take x common, what I get is 2 into x into 1 minus x into e to the power of minus x square. Now look at the option D. What they are saying is it's an increasing function in the entire interval 0 to 3 by 2. Okay. So the main observation here is this e to the power of minus x square is always positive, 2 is also positive, and the interval 0 to 3 by 2 x is also positive. But there is a clear problem with the term 1 minus of x here, because when x belongs to 0 to 1, it is going to be positive, but when x is greater than 1, it is going to be negative. So, which makes it 0 to 1 increasing positive value, so increasing function. But when x is greater than 1, you can say that 1 minus x is going to be negative, so which makes f dash of x negative. That is why f is going to be decreasing in the interval 1 to 3 by 2, which makes the option D also false here. Okay. Now we have verified only option A and D, right? So, but still we need to verify option B and C, which are the most important in this question, because it's a pure application of mean value theorems. Okay. So look at option B here. For every x greater than 1, there exists alpha belongs to 1 to x, such that psi 1 of x is equals to 1 plus alpha x. Okay. So let's take this psi 1 of x function. We know that psi 1 of x, which is equals to e power minus x plus 1, which is already given in the question. Now what I'm going to do is I will take an interval 0 to x, okay, where x is a positive value. X can be any positive value. So in this interval, I'm going to apply LMVT for the function psi1 of x. Okay, so what's our LMVT property actually for the function f? F dash of c is equals to f of b minus f of a divided by b minus of a, where c belongs to open a comma b. This is our LMVT, right? So I'm going to apply this LMVT for this function psi1 of x in the interval 0 to x. If I do that, I will get something like this: psi dash of c, psi1 dash of c is equals to psi1 of x minus psi1 of 0 divided by x minus of 0. So which means I will need this psi1 dash of c. So let me differentiate this one. Psi1 dash of x will be is equals to 1 minus of e power minus x. So the left hand side will be 1 minus of e to the power of minus c, where here c belongs to clearly 0 to x, which where x is a positive value, and which is equals to psi 1 of x minus, what is psi 1 of 0 here? Clearly 1, and whole divided by x. If you cross multiply, finally what we get is psi 1 of x is equals to, cross multiply and take this 1 to the left hand side, from which you get 1 plus x into 1 minus e to the power of minus c. So what's the observation here? When we take x as any positive value, so let me write down, for any x greater than 0, what you are able to conclude is psi 1 of x is equals to 1 plus x into 1 minus of e to the power of minus c. But what's the observation here? This 1 minus of e power minus c is clearly a value lying in between 0 to 1. We have seen this in the previous question also already, right? So if this is a value lying in between 0 to 1, and if I put this value as some alpha, what we are concluding is 1 plus x into alpha, where clearly in this case alpha belongs to 0 to 1 for any x greater than 0. But look at the second option here. They are saying that psi 1 of x will be expressed as 1 plus alpha x, and for every x greater than 1, alpha is greater than 1. Okay, alpha belongs to open 1 to x means alpha is greater than 1, they are saying. So for every x greater than 1, they are saying there is a value alpha which is greater than 1, which is satisfying this function. But look at this, we are able to conclude that alpha must be belonging to 0 to 1, which makes option B clearly false. Okay, so it's a pure application of LMVT. So as you can see, one single paragraph is involving too many concepts: definite integration concept, increasing decreasing functions, limits expansions, and also along with that mean value theorem. So I hope it was helpful to you, and then it has recalled so many concepts for us, right? So let me know in the comment section if it was one of the thought-provoking question which was asked in JEE Advanced from this chapter. Okay, thank you.